Okay. Double replacement reactions. This is when we have two compounds, or two ionic compounds. We're going to exchange the negative ions. This is going to be in aqueous solution. And this sentence doesn't really make sense. One of the following is usually true about the products. Solid, which would make it precipitation. Water, which means it's an acid-base neutralization. Or a gas, which we will see an example of that. So, we have this compound, which is composed of calcium and carbonate. We have this compound, which is composed of hydrogen and perchlorate ion. Keep the positive ions in the same order and trade the negative ions. Crisscross charges to get the compounds. Okay, here's the one where it makes a gas, because this compound right here immediately separates into H2O and CO2. CO2 gas, H2O liquid. The calcium perchlorate would probably remain aqueous. And we would need a 2 there to balance it. In the next one, this is lithium with a +1, carbonate with a -2. This is MO, molybdenum, and we know it's a +6 because of the 6 subscript on bromine. Bromide ion, -1. So, keep our positive ions in the same order and trade our negative ions. And we would get LiBr plus MO2 CO3 6, which is not something that we get very often, but we have that 2 and that 6, which we would reduce, so it would be a 1 that we don't actually write on the MO, and a 3 on the carbonate. Now we would need a 3 there and a 6 there to balance it. And that is a complete balanced formula equation. But we could look at our solubility rules and see that that's the one that remains soluble. So we could do a complete ionic, and we can do a net ionic. Our net ionic would be CO3 2- plus MO 6 plus yields MO CO3 3, and of course it always needs to be balanced. And let's do another one. So this is calcium, which is a 2 plus. Aluminum is a 3 plus. Aluminum was with hydroxide. So calcium gets it now. Calcium was with nitrate. We crisscross charges. A 3 and a 2 to balance the hydroxides. And we need a 3 there to balance the calciums. 2 there to balance the aluminum. And that balances the nitrates. And when we look at our solubility rules, we see that this would be a solid and this would be aqueous.